Greetings, honors pre-calculus students. Hope you're all enjoying your spring break. I wanted to send out a video to help you understand a piece of the extra credit project. One of the things you will have to do is construct the square root of an integer. And the video I'm about to show you will show you how to construct the square root of 5. And you want to kind of generalize this process so that you can use this to construct your regular polygon. Alright, as far as tools go, you're going to have two tools you'll need. One of them is just the compass. Some of you checked that out before you left school. If you didn't, you'll need to use or find one of those. The other one is really just a straight edge. I'm using a ruler, but technically speaking, you just need a straight edge. We will not use the markings of the ruler to assist in any way. That's just all I have on hand. So I'm going to start by literally just drawing a straight line on the paper with my straight edge. Again, I'm not using the links on the ruler to help. We're just drawing a straight line. And then what we're going to do is, since I want the square root of 5 to be my constructed length, I want to build a circle with a diameter of a unit 6 length. And the reason I'm choosing 6 is because you want your diameter to be 1 unit longer than the square root you're trying to take. So I'm taking square root of 5. I want to make this 6 units long. So how long is a unit? You get to decide that. So I'm just going to fix my compass to a certain length. It doesn't really matter how big, but we're just going to pick an arbitrary length. And you're going to take your compass and draw an arc that crosses through the line you just drew. So we'll copy that arc length, just making sure I line that up the same size. And we're going to draw 6 of those. So there's 2, and I always go back to the original to make sure I'm maintaining the proper spacing. There's 1, 2, 3, 4, 5, and that's 6. Okay. After the 6th tick mark, you could care less about the rest of that segment. So go ahead and erase the rest of it so you don't confuse yourself later in the drawing. And now this will serve as the diameter of our circle. So just so I can communicate properly on this video, we're going to mark off some points. I'm going to call my first endpoint point A. And I'm going to call the endpoint of the diameter segment or letter B, and that first mark that we constructed, I'm going to call that letter C. Okay. Again, this has unit length of 1, so I'll say that AC has a length of 1 unit, and we'll say that CB has a length of 5 units. All right, now our goal is to construct a circle with the diameter being the length of AB. So how do you do that? Well, we need to locate the center or the midpoint of that segment. And you know, the one we're doing right now is kind of easy. With a length of 6, we could go to the 3rd mark. Boom, there's our center. The only problem is not every time will you have a length that is an even amount. So we can't just divide by 2. If it's an odd number, the midpoint wouldn't have a mark, and so you can't measure because we can't use a ruler. So you really have to locate this point using a bisection method. So I'm going to take my diameter, and I'm going to kind of imagine about where the midpoint would be, and I just want to make sure my compass is wider than that length. So here's halfway, approximately. I'm going to widen that out a little bit. Make sure my point starts on the end point of the diameter, and just swing an arc kind of halfway around the circle there. And I'm going to fix that same length and just go to the other end and repeat that process. Okay, so we have something like this. If we did our construction properly, we'll have 2 points that we're going to work with now. I'm going to call that first point letter D, and I'm going to call the second point where those arcs intersect point E. And if you take your straight edge and connect those, as long as you built everything properly, it should go right through the center or the midpoint of the original diameter. And in this case, we did pretty darn good because we got that point marked off already. So, really nothing else in the diagram is going to be used other than this segment and its midpoint. So I'm going to kind of lightly erase these arcs that I drew. Keep them visible so we can actually see your constructions. But I'm going to kind of lighten those up. Obviously don't use pen for this. Keep them slightly visible, but just enough where they don't confuse you later on. Alright, so we have a midpoint of a diameter, and we're going to construct a circle at that center. So I'm going to take my compass, I'm going to put the pointy end at the midpoint. I'm going to line the other end up at the end point of the original diameter that I drew, and we're just going to swing this arc all the way around without moving it as much, try and keeping that steady. And that was pretty good. Okay, so now we have a semicircle. Our job now is to figure out a point on this semicircle that is directly above the point at the end of the 1 unit segment. So we're trying to find this point right here. So how do we do that? Well, the easiest way again is to construct a line that forms a right angle. So the process we used in the center at the midpoint of the original picture is going to get repeated right here. But really, we're only going to focus on, I'm going to put one more letter here. We're only going to focus on the letter C as the line or the point where we want it to come from. These points that surround it, so I'll call it point A and point D, are going to be the points that we use to construct the perpendicular bisector. So I'm going to put my pointy end on either A or D, and I'm going to make sure that the distance that, or the radius of the circle is larger than CD. So if I put it here, it's not big enough. Expand it out and kind of hold that steady. I'm just going to spin an arc. And now the tricky part is to maintain that same angle or that same radius. So I started it at D. I'm just going to rotate my paper and then do the same thing from A. Alright, so we have something like this. And if you kind of visualize a line coming up here, you can see that that's going to form a right angle with the diameter. So we'll put a couple more letters on here. We'll say, where did we leave off? E. We'll say this is F, and this is G. And I'm going to draw the segment from F to G and extend it all the way up. The length that I just drew, it's a little off. The length that we just drew is actually the length that represents the square root of 5. Straighten that out a little bit. There we go. And again, you can bring it down if you want, but the length from that point C up to the top, this distance from C to H will have length square root of 5. So let's say we picked this to be 7. This segment would have been square root of 7. If we'd have picked 13, this would have been square root of 13. So this is the length we were trying to construct right here.